All right, so it goes from -3 to 4, and then for the range, then part B, that's part B. Don't look at it left and right, look at it up and down. The lowest it got to is -2. Be careful, the highest it ever gets to is +2. And was there anything left out, up and down? Did we have any gaps in it going up and down? No, it went from -2 to +2. So -2 is less than or equal to y, which is less than or equal to +2. Okay. Part C. Okay, f of 1. What that means is this. I want to make sure that you look at, when you look at part C and part D, before I actually do C, look at D also, okay? C says f of 1, D says all x such that f of x is 1. Those are not the same question. Those are two total opposites, okay? What I want you to understand is this. If I give you this right here, I want to make sure we understand. Let's get very basic here. If I gave you this function, I say, what is f of 5? What did I do? I told you to plug in 5 for x. I'm telling you the x value, and they're asking for the y value. So when it says f of 1, I'm giving you the x value, and I'm asking for the y value. So when you look at this graph, where is x1? Right here. What's the y value? 0. What if I asked you f of 2? F of 2 would be what? 1. How about f of -1? 1. Okay? I'm giving you x, asking for y. So this is simply 0. Now for part D, now it says, give me the x such that f of x is 1. So in this case, I want to know what x values. Remember when we see f of x, we can change that to a y. We can just scratch it out, make it a y. Give me all the x values such that y is 1. So now I'm telling you what y is. I'm asking for x, or working backwards. So where is y 1? Right here. Is there any other place? Right there. Any other place? There's 3 spots where y is 1. So what they're asking for the x value or values. So there's 3 of them here. At -1, we have a y value of 1. At 1/2, we have a y value of 1. And at 2, we have a y value of 1. There's 3 of them. Okay? So again, I want to make sure you see the difference here. On part C, they're giving you x and asking for y. On part D, they're giving you y and asking for x. Okay? Now, part E kind of goes hand in hand with part D. Give me all the x such that y is not 1, but bigger than 1. Okay? So, think about it this way. Think about a thermometer, okay? The temperature is 1. Where is it going to be higher than 1? Well, above it. So where is it going to be above 1? Well, it's 1 here, and 1 here, and 1 here. So I'm just going to circle where it's higher than 1. It's higher than 1 in this area, and it's higher than 1 in this area. This right here is the cutoff. Here's where the thermometer is reading 1 degree. It's higher here because it's higher. It's higher here because it's higher, okay? Now they want to know the x values. What are the x values here? What x values did I circle here? Everything between -1 and what? +1/2. Everything between from -1 to +1/2, everything is above 1. Okay? Let me give it to you this way if you have a hard time seeing this, and a lot of times students do, okay? When you're reading graphs, like for example, let's go back to January, okay? Okay? If I gave you this right here, now you know this is the point 120, the point 210, and so forth, okay? What if I told you this, though? This stands for January 1st, January 2nd, January 3rd, January 4th, and so forth, okay? So on January 2nd, the temperature was 10 degrees. On January 5th, the temperature was 15 degrees. On January 6th, it was still 15 degrees, okay? What I'm getting at is this. The x values are where something happens, where it happens. The y values are what it is, okay? So on the date, on the 4th, the temperature was 5, on that time. So what I want to know is this. On what dates was the temperature 15 or above? On what dates? Where was it 15? Where was it 15 or above? Keep looking. The 1st and the 5th, and on those, at these times, at the 1st and at the 5th and at the 6th, it was 15 or above, okay? So what they're saying here on part E is, where was it above 1? You know the temperature was above 1 degree. It was between the -1 and positive. They're looking for the x value. So between -1 and positive half. So -1 is less than x is less than a half. Should I put equal signs under them or not on this one? This is a little bit tricky.
I don't think so.
Why?
Because you're saying it's above it, not on it.
Right. If I put equal signs at -1, was it above 1? It wasn't above 1.
It was.
It was 1. And at a half, it wasn't above 1, it was 1, okay? And then from 2 to 4, it was above 1, okay? 2 is less than x is less than 4. Everything between 2 and 4, and again, not including 2 or 4, because at 2 and 4, it wasn't above 1, it was 1, okay? Okay, let's try 3 more, then we're going to stop for today, and other than our homework quiz. All right. Not a lot of questions in this assignment, but they're a little tricky. They want to know, what can I plug in for f? So f of x is radical 2x plus 7. Okay, so can I plug in whatever the heck I want for x? Short answer is no. Can anybody think of a number I'm not? I mean, just give me a number, any number I can't plug in. Like, for example, can I plug in 5? You think 5's okay? Can I plug in 5?
Yeah, but
0's actually okay. I can plug in 0. 0's okay. I can plug in 5. I can't plug in -5 though.
oh, no negatives?
I can plug in -1. -1's okay. But I can't, you're on the right track. -1's okay. -2's okay. -3 is okay.
What does this even ask? Oh, no negatives where it makes the whole, because like, negative.
What's wrong with
-10,
-10?
it's imaginary, because it's a radical. No,
Why is -1 okay then?
because 2 times -1
Okay.
is 2.
I think what you're trying to say is
I
this.
don't know a way to put it into words. It doesn't.
You're not allowed to plug in numbers that create a what?
Negative.
A negative, okay? -1's okay. If I plug in -1, 2 times -1 is -2. -2 plus 7 is 5. I don't know the square root of 5, but we can take the square root of 5, okay? -3 is okay. 2 times -3 is -6. -6 plus 7 is 1. And I know that one, square root of 1 is 1. What's wrong with -4? 2 times -4 is -8. -8 plus 7 is -1. So, what we need to do, though, is find the magic number, okay? The number, now, you said you can't plug in a number that makes a negative. Can I plug in a number that makes 0? Is that okay? Can we take the square root of 0?
No.
Sure we can. What's the square root of 0?
0.
Why?
Because 0 times itself is 0.
Yeah, 0 times 0 is 0. We plug in 0. Okay, so let's do this. Let's see what makes this 0. So 2x plus 7 equals 0. Subtract 7. 2x is -7. By 2. X is -3.5. Or -7/2. It doesn't matter, okay? So if I plug in -3.5, what are we going to get? No. If I plug in -3.5, we're going to get 0. So is -3.5 okay? Yes, it is. What we can't plug in are numbers that are what?
Bigger than -3.5.
No. What can't we plug in? Numbers that are less than. So they want to know, what can we plug in then? Numbers that are what?
-3.5.
Right, bigger than or equal to -3.5. You can plug in any number bigger than or equal to -3.5, but anything smaller than -3.5 will be imaginary, okay? 23. Okay, 2 more to go. F of x equals radical 9 minus x squared. Okay, so, and again, I'm just going to throw some numbers out there, and then we're going to actually work through this. Can I plug in, give me a number I can't plug in. Give me some number I can't plug in. Anybody know it? Can I plug in 2?
Yeah.
Why?
Because it doesn't create a negative.
Right, what's 9 minus 2 squared? 2 squared is 4. 9 minus 4 is 5, that's okay. Can I plug in 6?
No.
No, I can't. 9 minus 6 squared is negative. Okay, so what we need to do, how about this? Can I plug in,
3.
Is 3 okay? What are we going to get?
0.
0, and 0 is okay. Can I plug in -3? What's -3 squared? It's 9. 9 minus 9 is 0, so that's good. Okay. Can I plug in 2? We already said 2, didn't we? Yeah, we did. Didn't we? Can I plug in 1? Can I plug in 4? No. Can I plug in negative 4? No. Let's do this. We can factor this thing. This is a difference of squares. 9 plus, 9. 3 plus x, 3 minus x. Okay? 3 plus x and 3 minus x. So what would make 0? What do I add to 3 to make 0? Negative 3. 3 minus what gives you 0? 3. And we already said this. If I plug in 3 and negative 3, we get 0. Okay? 3 and negative 3 gives you 0. You're all done already?
Well, right.
So, let's do this. Let's draw our number line. We've done this in the last chapter. Negative 3 and 3. Let's plug in a number like 100. Can I plug in 100? You should know what 9 minus 100 squared is. What kind of a number is 9 minus 100 squared? A negative. Negative something, okay? And then there's nothing squared here, so it's going to ping pong. Plus, minus, plus. What do we want? Where it's positive or where it's negative? What can't we take the square root of? What numbers can't we take the square root of?
3.
Just in general. Forget about this. What numbers can't we take the square root of? Don't say odds. I know what you mean to say. Not odds. Negatives. You can't take square root of negatives, okay? You can't. So what do we want? Where it's positive or where it's negative? Right. Because we can't take the square root of negative, okay? So what are we talking about? Numbers that are what?
Positive, we need numbers that are positive.
Okay, but I mean, where is it positive on my graph?
Well, there is there one in the middle of that?
Yeah, that's a positive. What numbers were those? It's not a trick question, guys.
It is always a trick question.
No. What numbers are those?
Negative 3 and 3.
Just those numbers?
Probably what's in between them.
Not probably, definitely what's between them. Okay? Between negative 3 and 3. We can plug in anything between negative 3 and 3. But if we plug in anything outside those, anything bigger than 3 or smaller than negative 3, what's going to happen? We're going to get a negative. So negative 3 is less than x is less than 3. Can I plug in 3 as well as negative 3? Or, yes, we can. Okay, last one for today. 25. Okay, says f of x equals x plus 1 over x3 minus 4x. Okay, so, anybody think of anything you can't plug in? We don't have any square roots, okay? So can I just plug in whatever I want? Tell you what, if I give you this right here, x plus 1, what can I plug in for x? What numbers can I add 1 to? Don't think hard on this. What? Any number. So I can plug in whatever I want. What if I give you this? I can plug in whatever I want for x except for one thing.
Negative 1.
Why?
Because you can't have 0 on the back.
Okay, so back here we were worried about negatives inside radicals. Now you're worried about what?
0 on the
0 on bottom, okay? Somebody think of something I can plug in here to make 0 on bottom? Can I plug in 0? What's 0 cubed minus 4 times 0? 0. So 0, you can't plug in 0. Now there might be more than that, and there is more than that, okay? Any idea what we can do on bottom? It's never a bad idea. One word. Rhymes with tractor. Factor. Can I factor something out of x3 and 4x? Something I can pull out of those?
Yeah.
What? X times x squared minus 4. That's a difference of squares. So x plus 1 over x plus 2, x minus 2. You could plug in whatever the heck you want for x, except for 3 things. What are you not allowed to plug in for x?
Negative, positive 2. And
Negative
0.
2, positive 2, and what?
0.
0. So instead of saying what x can be, in this case we're going to say what x can't be, okay? You plug in whatever you want except for x can't be 0, negative 2, or 2. Now again, I want to make sure you understand, we're not solving this. Sort of a trick question here. How do you solve this problem? Give you a clue. 3x plus 2x. Solve that. You can't. You can simplify it. It's 5x. If you don't know that, yikes. Okay? You can't solve that. Nobody can solve that. You can't solve this either. I'm not asking you to solve it. I want to know what are you allowed to plug in for x. And what we're saying is you can plug it in wherever the heck you want for x. Except for 0, 2, or negative. You're not allowed to. Okay? Because it would be undefined. You'd have 0 on bottom, like Luke said. All right, we're done with this for today. Okay, homework quiz time. I think I picked ones that were easy ones. I don't know. So let me shut this off.